So dear student, today once again we study about the block diagram reduction technique. Yesterday I told you about the rules and regulation behind the block diagram reduction technique. Now today we will start some numericals on block diagram reduction technique. In block diagram reduction technique, before starting the numerical, first of all I will once again tell you about each and every rules behind the block diagram reduction technique. Now see the rules. See the PPT. Yes. So this PPT yesterday I taught you about the block diagram reduction. Once again I teach you the rules first, then we will start the numericals. Are you able to see the screen? Wait for a while. Yes. Yes. So block diagram reduction rules. The first rule is what? Multiply the blocks in cascade. For example, a G1S and G2S are two forward gain of two blocks. If they are in cascade, then as in the figure, the gain of both the blocks will be multiplied with each other and the new gain will be G1 G2S. Means if the blocks are in cascade, just multiply their gain. The second one is move a summing point after a block. Whenever a summing point shift after a block, then the gain of that block comes with summing point. For example, RS is the input and CS is the output. Here from the summing junction there is a gain XS and there is a block gain GS, forward gain GS. If we wish to move that summing point before the which was present before to the just after the block, then what will happen? We have to put that gain with that summing point also. Here in this diagram, GS is the gain of that block after which we want to put that summing junction. So when we put that summing junction after the block, see then GS is also inculcate with the XS. Now if blocks are connected in parallel, similarly if blocks are connected in series, then what I told you in first rule, the blocks will be multiplied by each other. Now if the blocks are connected parallelly, then they will be added up to each other. See here G1S and G2S are the gain of two blocks. Both are connected parallelly and both of them comes in a summing junction with positive sign. So G1S plus G2S, they will be added up to each other. Then the next rule is moving a summing point after a block. Moving a summing point after a block. In second number rule we saw that if the blocks are connected such that if we wish to move the summing junction after a block, then the gain of that block will become. But here moving a summing junction before a block means if a summing junction will move before a block, then the gain of that block will be reciprocal and come with that summing junction. Here RS is the input and CS is the output. Here with the summing junction there is gain value XS and block gain is GS. If we wish to move that summing junction before the block, what will happen? The gain of that block which was GS is now comes with reciprocal such that 1 upon GS with that summing junction. The fifth one is pick off point movement, either before or either after. So in fifth, move a pick off point or take off point, but pick off point is also known as take off point after a block. So whenever we wish to move a pick off point after a block, if we wish to move a pick off point after a block, then the gain of that block will become with the reciprocal. For example, here RS is the input, CS is the output, gain of that block is GS, and we wish to move that pick off point which is related with XS to just after the block, then what will happen? The gain of that block which was GS now comes with the reciprocal in reciprocal manner. So RS is the input, GS is the output, CS is as it is the output, GS is the gain, RS is the input. Then 1 upon GS will be inculcated with that access, because we wish to move that before summing pick off point here just after the block. Now the last one is move a pick off point or take off point before a block. Similar to last rule, fifth number rule, if we move the pick off point now before the block, then the gain of that block comes as it is with that take off point. So here RS is the input, CS is the output, GS is the gain of the block, and XS is that summing junction related gain. So if we wish to move a pick off or take off point after a block, then what we will do, whenever we want to move, we can move it, but the gain of that block, which was GS, is also come with that access. So here it was a. So all of these rules are very much important related to block diagram prediction technique. In any graphical representation, in any numericals, whenever you saw a block diagram representations, we can change, because we wish to find out the transfer function CS upon RS. We can easily find out the transfer function CN upon RS, CS upon RS. Why this method? By applying all these rules, right? And remember one more thing, that as I told you, the transfer function is CS upon RS. It is equal to forward gain upon 1 plus or minus forward gain multiplied by feedback gain. But remember, if the feedback comes with the negative sign, then we have to use in this formula positive sign. If it was negative feedback, then we use in formula positive sign. If it was positive feedback, then we use negative sign in the formula. That's all. Now we just see some simple numerical and some complex numerical. So let's suppose there are certain numericals. For example, here you see two numericals. One is a very important numerical because it was already came in GATE 1987 of 2 marks question. So see, we just copy them and use in MS Paint file, and I will tell you about how to solve the numerical, how to find out the answer. So now see the MS Paint file. Wait, I just copy in MS Paint, and now I am going to show you. Yes, yes. So see, those two numericals are now copied here, and we just want to find out the answer. First of all, I just remove this one into a new file. Wait. Yes. So it was my numerical. Just I took from that PPT, and now first of all we have to solve this one. So see very carefully. The question was come in a competition exam related to a block diagram reduction technique. A very simple block diagram is given, and the closed loop gain of the system is, the question is what is the closed loop gain of the system. A system is given and 4 answers are given for objective question. So let's suppose how we can solve this question. So I just paste this diagram once again. Now see very carefully. -3 is the forward gain. This one is the forward gain. With the red color I just show you. This one is forward gain, as you know. Forward gain. And 0.5 is your feedback, because some part of the output whenever come in the input again, then that is known as feedback. So 0.5 is the gain of feedback. So it is feedback gain. Yes, output is CS and input is RS. We have to find out the transfer function, and we know that what is the formula for behind the transfer function? CS upon RS. So see, CS upon RS is equal to forward gain upon 1 plus or minus forward gain into feedback gain. So what is the forward gain? we just see minus 3 is the forward gain. I just mentioned minus 3 is the forward gain, so I just put minus 3 upon forward gain divided by 1 plus or minus 1 plus or minus. So here 1, because the see very carefully in this question with I show you with green color. See, the feedback is come with the positive sign, with this positive sign. Yes, so because positive sign is there, this feedback gain comes in input side again, in summing junction again with positive sign. So whenever positive sign is there, as according to the rule, we have to use negative value. We have to use negative. So forward gain divided by 1 minus forward gain multiplied by feedback gain. Feedback gain is 0.5. Simple. So what will be the answer? So see, this is equal to minus 3 divided by 1 plus 1.5, that is 2.5, that is 2.5. Yes, and definitely it will be equal to when I just did remove the point, then minus 30 upon 25, that is 6 5s are 30 and 5 5s are 25. Okay, minus 6 divided by 5. It is simple, minus 6 divided by 5, and this will be the answer, because the question was the closed loop gain of the system. Definitely the closed loop gain is the transfer function in this given diagram. So the closed loop gain of the system is minus 6 divided by 5. So whenever I see this question, I solve this question with the help of the block diagram reduction technique rules. A very simple rule, direct rule application is how to find out the transfer function. So this will be my answer. Okay. So we solve that first question. Now we will open the second question and see how to solve. Yes. So see, this one is my second number question, which was already came in 1987 GATE exam. A very good question. See here, for the system shown in the figure, what is the transfer function Cs upon Rs? What is the transfer function Cs upon Rs? And a diagram is given. So we have to solve this question. So I just put this question first of all at the right hand side. So we will solve it. Now this is the question. Now see, this is a block diagram representation and I have to find out the transfer function Cs upon Rs. So first of all, when I see this question, see there, as per this 6th rule which I have already been taught you via PPT method, how to solve the block diagram reduction. So see, there is a feedback, the inner feedback. I just draw it with the help of this pencil. See. Yes, this. Yes. So see, first of all we will solve this one. This one is what is the forward gain? I just type with the green color to show you that this is my forward. Here for this block, this will behave as a forward gain. This will behave as a forward gain. This will behave as a forward gain. Yes, and this S will behave as a feedback gain, as I told you. This S, this one. Yes, this S will behave as a feedback gain. So first of all we solve this one. So first of all we just solve this inner block. So we know that how to find out the gain of any block diagram, transfer function of any block diagram. I am talking right now about the inner block diagram, right? So how we can reduce it? Forward divided by 1 plus or minus forward plus or minus feedback. Once again I repeat, forward gain upon 1 plus or minus forward gain into feedback gain. So what plus or minus, which one I have to use depends on what is from which side the feedback comes. So see, with this orange color I showing you this feedback, this S will come here at the summing junction side with the negative sign. So I have to use positive. I have to use positive. So what is the solution of this inner block? We just, how we can reduce this inner block? By using the method forward gain. So what is the forward gain? 10 upon S, S plus 1. So forward gain divided by, so divided by 1 plus or minus forward into feedback. So 1 plus or minus, but here, wait, but here I have to use only the plus because the feedback come with the negative, because negative feedback is there, So 1 plus forward into feedback. So what was the forward? Forward was same 10 upon S, S plus 1. Multiply by feedback. So what is the feedback? Feedback is your S. Yes. So this one. So how we can solve the inner block? Now this L will I will solve this. See, so when I solve this one, yes. So 10 upon S, S plus 1. So I just solve this one. So 10, I just put tag S, S plus 1 as a denominator, LCM. S square plus S plus 10S. S square plus S plus 10S. S square plus S plus 10S. Wait. This one will be square. Yes, so S square plus S plus 10 is, we can say S is 10 upon S square plus 11S. S square upon 11S. So I just, you can say 10 upon S square plus 11S. 11S. Okay. So now this will be actual representation of that inner block. This will be there. Sorry. So this will be the actual representation of that inner block. What I mean, once again see, now the diagram will be reduced such that now when you want to solve this one, the diagram is now reduced, the inner block is totally deleted, and now the instead of that inner block, the value of that inner block we have to write down. Only this value will become with the help of a rubber. I help. Yes. Yes. Now the block diagram is changed according to our calculation. So now this will be your new representation of the same question. So now we have to find out CS upon RS. So once again there is a block. After solving the inner block, we find the question will be converted into a new form of new representation of a block diagram, in which the forward gain is 10 upon S square plus 11S, and what is in feedback? Only a straight line. Only a straight line. Whenever a straight line means the output directly come at the summing junction in feedback directly, means with the help of a straight line, then it means the gain is 1. So I just represent this with the help of, let's see, this blue color. See this one is your forward gain now. This one is your forward gain now, and this one will be your feedback gain. This straight line is your feedback gain. Wait, I adjust. Yes. Yes, this one is your feedback gain, that is equal to 1 because a straight line is there. So now how to solve the question? Because we have to find out the transfer function Cs upon Rs. So now Cs upon Rs Cs upon Rs equal to Cs upon Rs equal to forward gain upon the rule is same, forward gain upon 1 plus or minus forward into feedback. So what is the forward gain? Forward gain is 10 upon s square plus 11s. So just I put this same value, forward gain divided by 1, because with negative sign the feedback will be there, so I have to put plus because positive sign. So forward into feedback. So forward is this, and what is feedback? Feedback is nothing, it is equal to 1 only. It is equal to 1 only. So there will be no meaning to write down the feedback gain because 1 is the quantity. So what will be your final answer? When I put the s square plus 11s as a LCM from the LHS side, then I will find 10 upon s square plus 11s plus 10. That will be my answer. S square plus 11s plus 10. Yes. So this will be my final answer because now the block is totally reduced. So what is my answer? Seen in purple color I just mentioned, my final answer is this one. So my answer of this is s square 10 upon s square plus 11s plus 10. So what will be my answer? 10 upon s square plus 11s plus 10. B is my correct answer. So it was already been come in GATE exam, and now we are able to solve with the help of the basic block diagram reduction rules. So thanks for watching my video. Today we solve two numericals, a very simple numericals based on the block diagram reduction techniques. I have already been taught you block diagram reduction rule. Today once again we repeat all those rules and do two simple numericals on block diagram reduction. From the next class we will see some more complex numerical on block diagram reduction technique. Okay, thank you very much.